Hello everybody and welcome to the next episode of After Effects A to Z. My name is Multanen and today we're gonna talk about audio spectrum. Oh, and honestly, for those of you who know me, you probably know that this is not my voice and it's not me and it's not George. Those guys are gone. You can call me McLovin. Oh yeah. So, we're gonna create a new comp out of this wave file. So we have a composition with the proper length, of course, and we're gonna create a new solid. I bet you didn't see that coming, right? Okay, so let's make some room here and apply generate audio spectrum, and let's make, about making some room, huh? We don't need this anymore, but we need these controls here. Okay. So first of all, we have to choose our audio layer, which is music. Okay. And as you can see, when I scrub the time indicator, the layer animates. Quite obvious. But if you remember the previous tutorial, which was about audio waveform, this looks a little bit different. In audio waveform, we saw the actual waveform being rendered and kind of moving from left to right. And here we just have those bars that get scaled up and down according to music. So what's the difference? Well, the main difference is that audio waveform was rendering the velocity while audio spectrum renders the frequencies. That's the easiest way I can explain it. So for example, in this audio file we can see a lot of low frequencies being displayed, and the further along the spectrum you go, the less frequencies we see. So we can kind of imagine that this is a very bassy music, probably a lot of drums and bass guitars and stuff like that. So let's just quickly go through the controllers we got here. First of all, we've got, of course, the starting point and ending point, which define the area on which audio spectrum is being rendered. We've got the path, which works pretty much the same as it did in audio waveform. If I'm just going to draw a path here and I now choose it, we're going to have our render spread across that path. So I'm just going to get rid of that and reset all the settings, get rid of the path as well so it doesn't get in the way, and set our music layer back on. Next parameter in line is use polar path. And that actually uses only the starting point. So to demonstrate how it works, I'm just gonna move it here. And as you can see, it doesn't look very much impressive. So to see it better, we gotta pump up the maximum height. And that way, you can kind of see what's going on. The whole line, the whole audio spectrum we had rendered before is now wrapped around a single point in a circle. So that's how it looks. It creates kind of nice looking effect. So that's that. But we already moved to maximum height and we should focus on the previous settings. So let's just go back to regular render, probably reset all the settings again. And yeah, that's right. Let's continue. So we've got start frequency and end frequency. This is the frequency range that audio spectrum is analyzing to create the render for us. Lower frequencies are, instruments like bass and drums and stuff like that. And the higher pitch or the more squeaky sound you can hear, the higher frequency it is. So if you want to change the range, for example, in here we can see that most of the action happens around this area. So to emphasize that, we can actually trim down the end frequency just like that. And as you can see, notice this bar. As I'm lowering the end frequency, it moves to the right because basically we're just trimming the whole audio spectrum that we're analyzing. See? It just kind of moves in this direction, right? So that's that. Pretty handy a little tool, but make sure to not to overdo it, because then you're just gonna end up with something like that, which can look kind of strange. But that's up to you, of course. So let's go back to a default setting of 2000. The next one in line is frequency bands. This is pretty self-explanatory. As many bands as we have, as many lines we're gonna get. So that's pretty much it. Next, maximum height. We already talked about this one. So let's focus on audio duration and audio offset. Those two parameters work similar as they did in audio waveform. Basically, this is the amount of audio that we're analyzing for those frequencies, and this is obviously the offset we want to use. If I'm going to move it to the negative value, for example, like that, you can see that now, even though the wave file is still here, we can still see the spectrum, which is not correct, right? And here, even though the audio is still here, we don't see anything. That's basically how offset works. So let's just set it up to 0 and see if that looks the way it should. Yep, it does, as you can see. So let's just throw this down. We don't need it anymore. And let's go back to audio duration. If I'm going to trim this value down, see what happens. Right now we've got 2 milliseconds, and in this short span of time we can only hear the bass beat basically, and this is why it changes so rapidly. So basically you want to keep it quite low to have a more dynamic render, but high enough to have the whole spectrum visible. So about 90, which is the default value, is quite okay. I'm going to lower the frequency bands for now because we're going to need it for demonstrating next parameters. The next one in line is thickness, pretty much self-explanatory as well. And softness, pretty much like feathering, as you can see. The next one are inside and outside colors. We can change those. For example, white and red for the outside. I think those two parameters speak for themselves. So let's just see what this blend overlapping colors does. Basically, it separates each band and puts it on top of the other. So we get a basically overlapping effect like the one you see right now. But the most fun parameter, the one that I like most, is hue interpolation. Because this actually allows you to create some very nice looking audio spectrum graphics like this one. And you have to remember that this is hue interpolation. This doesn't just color these bands. It offsets the color, the outside and the inside color, exactly this amount that you set in here. So for example, if I'm going to change the red color to something else, this whole hue is going to shift as well. Check this out. Okay, so I don't think that it's that important unless you want to have a very specific color for a very specific frequencies in your audio spectrum. But I don't think any one of us is paying that much attention to detail. So let's just leave that. Also, we've got dynamic hue phase. This actually shifts this parameter along to the intensity of the audio. If you take a look at this, you will see that those greens and reds basically shift a little bit left and right as I scroll through the audio. But if I'm going to switch this off, all colors are going to stay in the exact same position. Also, we've got color symmetry, which basically, as you probably noticed already, when I change the hue interpolation, the colors move in both directions, left and right, from the middle of our render. If we turn it off, it's going to go from left to right, just like you would expect it. And this is what I use most of the time. And the next one in line is display options. We've got digital, we've got analog lines. I'm just going to change the thickness a little bit so we can see the difference. So again, digital, my personal favorite. We've got analog lines and we've got analog dots. Basically, I don't think there's anything more I have to say about these parameters. Let's maybe just click composite on original so we can see this a little bit better. Yeah, we should have done this from the start. Okay, and of course we've got side A and B. Side A, which is the top, and side B, which is the bottom, and of course both sides. And this works for all the parameters, digital as well, for example only the top side or the bottom, and the same for the analog lines. But for now let's stay with digital. As I said, this is my favorite, and let's stay with side A and B. And the last parameter is duration averaging, which I hardly ever use. This actually averages the height of the frequency bands according to the length of your audio. So honestly, I hardly ever use this parameter because you can't really tell what it's averaging like for sure. So basically, this is the setup that I'm using. Sometimes I'm just using side A and create side B as a reflection, for example, just duplicating the layer, flipping it upside down, changing the mode to add, and maybe blurring it out just a little bit. Like that. Like that and like that. And then adding some linear wipe to it. Wrong direction, 180. Yep. And here we go. Looks quite cool, doesn't it? So this is just one example of how you can use this, but I'm sure you can find many other ways of using this plugin in a very creative manner. So once again, thanks for watching. My name is Multanen, and see you next time. Cheers.